All right, ladies and gentlemen, so I posted a different video that goes through kind of the biggest, hardest ones, but then we also have some other decisions that we can make, and we can do some other solving using some factoring and that kind of thing. So I thought I'd go through and talk about kind of each piece that you can see there, what to look for, and how you would know when to solve that way. So one of the things that you may see is when we have two different chunks of two terms. If you see two terms, you'll still want to do the same thing we've always done to start these. Say, hey, are there any common factors? Is there anything that we can take out of all of these? If they're numbers, we can just divide them everywhere and say, I want to divide everything by 2 or by 7 because it's an equation. We can do that. We don't want to do that with variables. We're going to want to factor variables out front. So if you look at this first example in black here, there are no common numbers between 9 and 16, but we can take an x out of this whole thing because they both have x's. We can take an x out of each. There's only one because this just has the first power here, so we can only take the 1 out. And if we do, you'll get something that looks like this: 9x to the 4th now minus just 16. So what this does for us is it actually gives us one of the solutions. Remember, we're looking for 5 solutions here because it is the 5th power. But every time that we get to factor one of those x's out, we actually get to just say, hey, x equals 0. That would solve this. And this happens quite often, ladies and gentlemen. A lot of times we just put an extra x in there. And one of our solutions, if you factor that x out, ends up being x equals 0. So that is one of our factors. And we're kind of just left with, hey, well, now we have almost a new problem, right? That's what happens with a lot of these. We kind of peel answers away and we keep solving smaller and smaller problems. So now I'm really looking at 9x to the 4th minus 16. And you could go through and you could plug this into your calculator and you could find something and divide. You'd have to be pretty careful because you do have to write those zeros if you did it that way. But if you think back to factoring, this is actually something we can factor. And if you realize that we can factor it, it does make our life quite a bit easier. We can chunk this into two things, right? If I have two terms, we should be thinking either, is this the difference of perfect squares, meaning is everything in here squared with a minus in between? Yes, in this one. Or the next problem we're going to do over there in red is actually the sum difference of cubes, and we can fix that one a lot. So we'll do that one after. But we can say, hey, this is 3 squared, and this is 4 squared. Oops, 4 squared. So I can actually factor this red equation into, hey, 3x squared. Now that this has a 4th, normally we were doing it with x's, but now instead of just having 3x, that x to the 4th breaks into x squared, and you multiply these back together, you get 9x to the 4th, so that's where kind of that breaks out into. And then the 16 in the bracket breaks into 4 and 4. And just like before, we need one of these to be plus and one of these to be minus. This is the difference of perfect squares. It's kind of like a formula or a rule that we've been doing since Algebra 1. The new part is for sure that we have x squareds here, but x to the 4th breaks into x squared times x squared. Should make some sense. From there, the nice part is all we're really doing now is we're solving these two things. 3x squared plus 4 equals 0, or 3x squared. Because remember, the whole thing that we're really doing is we're trying to get these down to like x squared stuffs. Because once I have x squared in my equations, I know how to deal with those. I can either solve by square roots or quadratic formula or factoring or something like that. So if you look here, we're actually going to solve these by square roots because there is no b term as you go through, right? There's an x squared and there's a number, there's no b term. So I'm going to subtract 4 here. We're trying to get x squared by itself. And if I divide by 3 on both sides, x squared equals, this is negative 1.33. That repeats a little bit. And if we take the square root of that, x equals, there's a negative there, so we're going to take the square root of the positive 1.33 repeated there. Second function square root of 1.33 is 1.15. And because there was an I there, or a negative there, we're going to say I. And then for the second part here, it's going to be the same numbers just without the I. So if I add I this time. We get x squared. Positive 1.33, or just, oh, and I forgot a plus or minus here, and I need a plus or minus here as well. So don't forget those. They're easy to drop, and they are pretty important on our test. Remember, we're looking for all the solutions. So this is 1.5. So we get one with an I and one without. Each of these is worth two answers, one plus, one minus, for four down there, and then this one here. So we would write our final answer as equals 1 plus or minus 1.15I plus or minus 1.15 without the I and 0. This would be our 5 answers. This is 5 total answers because of that. 2, 2, and 1 for a total of 5. So that is something you might see with the difference in perfect squares. That's what happens when we see two terms. The other thing that we see when we see two terms is here in red. First, similarly, we're going to factor out a GCF first. There's no numbers I can divide since there's a 1 in front, but we can take an x out. That's fine. That just means x equals 0. Once again, I can slap this on every problem, so I kind of likely will. You can just put it on there. It makes the problems a little bit more difficult, but not really, right? You're just peeling an x away. It's one of your solutions. Great. Okay, but then we're going to factor this guy. And remember, one of the other things I can do with cubes is if I see this here. We have a formula as long as everything is cubed in here. It doesn't even matter if it's plus or minus. We have a situation for both. This is just 9 cubed. That's 9 cubed. X cubed is obviously x cubed. So we're going to use that formula that we wrote down in our notes where a is equal to x in this case, and our b is going to be equal to 9. And this factors into x plus 9 times x squared, minus 9x plus 81. Okay. These signs depend on whether there's a plus or minus in my original equation. So since that was plus 729, I used plus minus plus. If there was a minus in there, it would go minus plus plus. So it always goes the same on that front one, then the opposite, then always plus from there. So then we do need to get 3 different answers from those. One of which will just be x plus 9 equals 0, or if I subtract 9, x equals -9. That's a great answer. And then the other one, you almost always have to use the quadratic formula for it because it does have imaginary solutions. We'll go in here. If you look at this one, A is 1, B is -9, and C is 81. You'll need to go in and plug that into the quadratic formula. You'll likely get some imaginary solutions. Let's check it out. So that means x equals -b. Opposite of -9 is 9, plus or minus the square root of -9 times, or -4 times 1 times 81. All over 2 times 1. So I'm just plugging that into our formula. We should at this point be able to use the quadratic formula pretty actively. We did a whole unit on it. So I'm kind of jumping through this quickly. This is x equals, your calculator can find that whole square root. If I do, whoops, I forgot my squared up there. Forgive me. Squared. It's -9 squared. So we're going to say parentheses -9 squared minus 4 times A, which was 1, times C, which was 81. And you get -243. Oh, no, that's fine. We expected the I. Oh, I'm going crazy. Cool. All over 2. And the nice part here is that since we have a negative square root here, we're just going to take the square root of 243, and we're going to slap an I on it. So it's going to say 9 plus or minus the square, or not square root of. If you take the square root of 243, you get 15.59. Oh. We do need an I on there because this was a negative square root here, and all over 2. So this is my final answer here. So when you go to write your final answers for real for all of them, we have that 0 that was up at the top. We have this x equals negative 9, and then that whole chunk. So it looks something like this. In red here, this is a total of 1, 2, 3, 4 answers. And if you look back into what we started with, we have 4 answers. That should always happen. So that's anything that you see that has just 2 terms in it. Those are the only ways we can solve these with 2 terms. And then the last thing that you might see, so you might see a 4-termer. The other example video that you'll see today, or that you can use to do all of these problems, goes through one that looks a lot like this, and you can't factor it. This is an example of a problem that you can factor. So I suggest factoring by grouping if you can, because it does make your life a little easier. So just like before, we'll check and say, hey, can I divide everything by the same thing here? See a 3 in front and an 8 in the back. 3 and 8 don't have any common factors, so that's fine. But I can take an x out front again. Cool. So as always, this just means that x equals 0 is a solution, and it's part of our solution set. It needs to be is our answer at the end. And it's one of our 4 that we expect to see in our final answer. Otherwise, let's go deal with these. So we're going to say, well, all right, well, now I have 3x minus 12x plus 8x 0. So last time we just plugged it in our calculator, and then we used that to divide out and find one of our solutions. You can still do that. You're more than welcome to. If you like synthetic division and you're good at it, go ahead. But if I group these two, I can take out 3x squared, which leaves me with, if I divide by 3 and steal 2 of those x's, I got x minus 4 in here. Great. And then if I group these two, what did I have to take out of here? Well, that's a positive 8. I can divide both of these by it, and I get x minus 4. And look at that. That actually works, and that's nice, right? These insides actually match up, which is cool. So the front stuff, 3x squared plus 8, comes into one factor. And the inside stuff, x minus 4 equals 0. So now I can solve these two things. So without having to go to my calculator and having to graph it and find those solutions, we can just jump in factor, which is great news. So this actually worked out. Now I just say, well, 3x squared plus 8 0. I better go do some division here. If I subtract 8, 3x squared equals negative 8. And then I got to divide by 3. Fine. That gives me a decimal. That's okay. So x squared equals, what is that? Negative 2.67. And if I went and square rooted that, what do we get? Don't forget your plus or minus. Take the square root of the positive and slap an I at the end. Second function, square root of 2.67. I get 1.63 equals plus or minus 1.63 I. Don't forget the I there. This one is imaginary. The other one just comes out and says x minus 4 0. Or if we add 4 to both sides, equals 4. That one was quick and easy. Wow, so there's a lot going on here. So let's double check and make sure that we have all of our answers. How many did we expect to see? Well, at the beginning, we expected to see 4 here. So I have x equals 0, that's 1. I got a plus or minus here, that's 2, 3, and then 4 is cool. So x equals plus or minus 0.63 I, 0, and those are all my values. So if just because it has 4 terms doesn't mean you have to use the graphing calculator, you still could have. So that other video that I'll post as well, that goes through using like a 4-termer here that you can use the calculator on and find a factor that way. So we could have still found that factor of 4 that is in there, right? The 4 that we got from doing it algebraically, you could have found in the calculator divided by 4 and still gotten this other option. So lots of ways to do these, lots of different things to do. So yeah, that's kind of all of it, I think. Make sure to come with questions and let me know what you need to see. Thanks, ladies and gentlemen.